Earth throughout its geologic history has gone through many, many major changes. And basically what we're going to be looking at in this section is how we take the evidence that still exists from those major changes or events that have happened in Earth's history and reconstruct and get a picture of what actually happened. So to do this, what we're going to be looking at and expecting you to do eventually is to demonstrate an understanding of how various methods used to determine an object's absolute age can be combined with other geological evidence to reconstruct major changes or events that have occurred within the Earth system throughout geologic time. So to do this, we're really going to begin with some basic geologic laws. So an introduction to geology. This began back in the 1700s with this scientist, James Hutton. When you get the chance, I highly suggest you watch this video. It's a very interesting backstory. A lot of these laws will be covered in that video in a much more interesting and visually appealing way. So definitely check out the video. It'll help you do this. But first we're going to jump into and kind of go over his contribution. So James Hutton, he was a Scottish scientist. Basically was one of the first scientists who looked at and really started analyzing and collecting data on how rocks formed and the types of processes that were involved and how long that took. So he came up with this concept, he called it the principle of uniformitarianism. This is just a fancy way of saying that the processes that form rocks today in the present are the same processes that form rocks in the past. So basically those processes have never changed. Rocks have always formed in the same way, and they will continue to do so in the years to come, and those processes are never going to change, and it takes a really long time is basically what he identified. But to do a quick review on the different rock types and what he was doing as a scientist, he was one of the first scientists that really tried to explain how these rocks form. So for example, sedimentary rocks. We know today that sedimentary rocks only form in the presence of water, so you need some form of body of water in order for them to form. Basically what happens is the water transports those sediments, and as the water enters the body of water, it slows down and it starts to deposit those sediments onto that the floor of that body of water. So those sediments over time pile up, they begin to compact, and then eventually they cement together, creating your sedimentary rock. And that might look something like this. This is a good example. You can see the layers of sedimentary rock. In this case, it kind of looks like the Badlands National Park. But alright, next type of rock, igneous rocks. So igneous rocks always form from molten rock cooling. Whether it's magma below the surface or lava entering above the surface, anytime molten rock cools, you're going to create an igneous rock. So depending on the rate of cooling, you get all sorts of different types of rocks. One of the most common igneous rocks you're going to see here in New Hampshire is granite. The granite we have here, because it cools over a long period of time, you get really big crystals in it. Granite's probably considered to be one of the world's toughest rocks. It stands up really well against erosion. The only difference that you would see compared to this image and what you would see around New Hampshire is these white crystals in New Hampshire tend to be more of a orange or pinkish color. So it has a really vibrant color to it when you look at it from New Hampshire, and that's known as Conway granite. The last type of rock is a metamorphic rock. So anytime you take a rock and put it under heat and pressure, you'll form a metamorphic rock. So all these types of rocks, I mean, all it is a classification of how they formed. Any of these types of rocks can go back and forth between one type or another over really long periods of time. Today we're going to focus mainly on sedimentary rock. So a little more information on that. Sedimentary rock, again, it's a combination between erosion and deposition. So erosion takes those sediments and transports it to the body of water, and then once they enter the body of water, those sediments are deposited into the geosphere, basically, where they're compacted and form that sedimentary rock. Due to this formation and this process, sedimentary rocks always form in horizontal layers. This actually has its own law. It's called the law of horizontality. And you can really see that when you look at images like this, so those nice horizontal layers. So anytime something becomes layered like this, it's breaking down into what we call strata. It's stratified. Strata is just another fancy word for layers. So sedimentary rock is a stratified rock if you want to look at it that way. Relative age. Okay, so now we're going to get into some of the basic principles of geology. Relative age is a quick way to compare one rock to another without getting into too much detail or too much time and effort to analyze the actual age of that rock. So basically, you could kind of do the same thing with your friend. So for example, comparing all your heights together. So if you had a group of friends and you lined up by height, you could figure out your height relative to everyone else in your group of friends. So from shortest on the left to tallest. You wouldn't know exactly how tall each of your friends are. You're just comparing your height to your friends. So that would be like a relative height. You could even do the same thing by age. So if you lined up by age, you could actually compare your relative ages without actually knowing your exact ages. You could figure out who is younger or older compared to one another. So we do the same thing with rocks, especially when they're in horizontal layers like this, which leads us into our next law. So this is a picture of the Grand Canyon. We'll come back to this in a sec, but what makes the Grand Canyon really famous is you can actually see all these strata, these sedimentary rock layers, and we can compare those layers to one another. And this law is known as the law of superposition. And all this law states is that when rocks are not disturbed, so meaning they're still in their original horizontal layers and they've never been tilted or flipped or anything, they're basically still in their original state. So when they're not disturbed, rock layers are older than any layers above it and younger than any of those below it. So what's that say? It basically says any of the rock layers on the bottom are oldest and any of the ones on the top are the youngest. So in this case, mudstone would be the youngest rock and the rock that's presently still forming, while the conglomerate would be the oldest, and it would go right in order from youngest to oldest. So mudstone, siltstone, limestone, sandstone, conglomerate. So this is a really basic law, and again, you could apply it right to this image. So we know that the horizontal rock layers at the bottom of the Grand Canyon are much, much older than the rock layers that exist at the very top of the Grand Canyon. Okay, so the second law we're going to go over, actually third law, is known as the law of cross-cutting. Basically, this looks at when a fault or another body of rock is forced to cut through an already existing rock. And all this law states is you can't cut through a rock if it doesn't already exist. So that fault or new body of rock that's cutting through has to be younger, because that older rock had to already have existed in order to cut through it. So here's kind of an analogy. You can't really break bricks if the bricks don't exist. All right. In geology, anytime you have igneous rocks that cut through other rock types or other rocks in general, it's known as a dike. It's an intrusive type of volcanism. And looking at this image, you can kind of look at what cuts through what. So in this case, we have three of them, A, B, and C. And if you look at C, C cuts through all of the sedimentary rock layers. So all of the horizontal rocks, C cuts right through it. So we know C is actually younger than all of those sedimentary rock layers. If we looked at B, we can see that B cuts through C, so B would be younger. And then A cuts through B, so we know that A is the youngest rock out of all of these rocks shown. All right. And this law of cross-cutting you can apply anywhere in the world. You can find evidence of these intrusive volcanics basically wherever you go. So here's an example kind of close to home, Schoodic Point, Acadia National Park up in Maine. And this is a picture I took a few years back. And this is all igneous rock. So we're looking at this black rock, which is an intrusive volcanic rock that cut through this orange block of granite. And you can actually see this is kind of interesting because the black rock doesn't stand up to erosion as well. So over time the ocean has done a really good job of eroding that black rock. So in this case we know that the black rock is younger than the blocks of granite because it cut through that granite. We can see here's some more evidence. This is also in Acadia National Park. And you can see the same thing, these black, I think it's dacite, maybe even a basalt in this case. So this dacite is basically cutting through the granite, which makes it younger. And an example a little closer to home where you can't actually see the intrusive rocks cutting through, the flume formed in a very similar way. So this intrusive volcanic rock cut through and split apart the granite, and then the stream over time eroded that rock down. So I mean, this helps explain a lot of the things you'll see around, and also helps you identify some past events that may have happened in whatever area you're looking at. So typically you'll see this where it was volcanically active at some point. So these are all examples of volcanism at some point in New England. And then this is an example out west. This is Crater Lake National Park. This rock out here in the middle of the lake is known as Phantom Shipwreck. And this is actually the remnants of an intrusive dike that cut through the entire volcano before it collapsed. In this case, this intrusive rock was a lot tougher than what collapsed in the volcano. Because of that, it stood up well, and you can actually follow the spine going right all the way up the cliff face. So that's just another example of evidence that you might find wherever you travel, if you ever get the chance. Crater Lake's amazing too. Okay, so if you like to test your understanding, we're going to go over this in class. But basically your goal in this task is to determine the relative ages from youngest to oldest of letters A, B, C, D, and E in the following image. So this image right here. So can you figure out, based on these laws, can you apply these laws to this image and figure out of A through E which is oldest and which is youngest, and put them right in order? So I'll let you do that and we'll discuss it in class.